Most of us assume our eyes work like high-end video cameras, recording the world exactly as it unfolds in front of us. The biological reality is quite different. The act of seeing begins in the eye, but it isn't completed there. Without the brain, the eye is effectively blind. It serves as the initial mechanical link in a long chain of data collection and translation. The old saying that seeing is believing misses the mark. Our visual reality is a neurological construction, a model built by the brain rather than a direct photograph of the outside world. If the eye isn't actually comprehending the world, what is its actual biological purpose when we look at something? Think of the eye as a specialized biological sensor. Its only task is to physically intercept and manipulate incoming light waves. This creates a partnership between hardware and software. The eye captures raw data, while the brain runs the simulation that we experience as sight. This journey begins at the cornea, the clear, dome-shaped outer layer. As the first point of contact, it refracts incoming waves, accounting for 70% of the eye's focusing power before light reaches internal structures. Once past the cornea, the light travels through the pupil. Surrounding it is the iris, a dynamic ring of muscle that dictates how much light is allowed to proceed. In low-light environments, the iris pulls wide. It expands the pupil to capture as many photons as possible from the surroundings. In bright light, the iris contracts, shrinking the pupil to a tiny point. This prevents the sensitive internal tissues from being overwhelmed, performing the same function as the aperture on a camera lens. Nature developed this autonomous system to regulate light intake with incredible precision, a feat humans would only replicate millions of years later with mechanical cameras. After the iris filters the light, the beam makes contact with the biological lens located just behind the pupil. While a camera uses a rigid piece of glass or plastic, the human lens is a living, flexible tissue that constantly alters its own physical shape. To see up close, ciliary muscles contract. The lens bulges to sharply focus short-distance light onto the back of the eye. When looking at the horizon, the muscles relax, and the lens stretches flat to process distant light. Scientists call this organic zoom feature accommodation. It is a constant, real-time recalibration of your internal optics. This ability to physically reshape the lens allows the eye to maintain focus across varying distances with incredible speed, a feat that remains difficult to replicate in most mechanical systems. At this point, the light has been filtered and focused, but it still has no meaning. The eye itself does not know what it is looking at. The focused light hits the retina, where it is converted into electrical pulses. This raw data travels down the optic nerve, leaving the eye entirely and entering the visual cortex of the brain. The brain receives this data as a two-dimensional, upside-down projection. It must immediately flip the image, calculate depth to add a third dimension, and assign identity to every shape and color detected. This reconstruction is so dependent on the brain's internal logic that when the incoming data is ambiguous, the brain fills in the gaps based on its best guess, which is exactly how optical illusions trick us. Ultimately, the eye serves as a precise light gatherer, but the final image you see is a mental recreation. We don't perceive the world exactly as it exists. We perceive the version our brain is able to build.